Hello everyone, this is lecture 68 of Principles of Electric Circuits. We will discuss complex power. You may be surprised why we define so many powers under SSS. We will summarize a clear answer in this lecture. For such a one-port network containing RLC and dependent sources under SSS, we assume that the voltage phasor is and the current phasor is. We know that the active power absorbed by the port is. By using Euler's formula for cosine part, we know that. So the active power can be written as we can write further. Do you find that this is a voltage phasor and this is a conjugate of the current phasor? So we know that. Similarly, we know the definition of the reactive power is through a similar derivation we can get that is to say, the active power absorbed by the one-port network is a real part of U timing I conjugate, and the reactive power is an imaginary part of U timing I conjugate. So we can give the definition of the complex power. Here the star means conjugate. The unit of the complex power is also VA. Because the active power and the reactive power are conserved, so the complex power is also conserved. In order to illustrate the relationship of the apparent power, the active power, the reactive power, and the complex power, we might as well draw the power triangle. By such a power triangle, we can see the relationship between the definition of several powers very clearly. We know that the active power, reactive power, and the complex power are conserved in the circuit, but the apparent power isn't conserved in general. Next, let's review the problem introduced at the beginning of lecture 65. In order to calculate the power supplied by the source, we use U times I1 directly. In order to calculate the power absorbed by the load, we directly use U2 times I1. In order to calculate the power absorbed by load Z2, we directly times U3 with I1. It's clearly wrong. But with the complex number, we first calculate the complex number supplied by the source. Next, we calculate the complex number absorbed by Z1. We continue to calculate the complex number absorbed by Z2. Through numerical comparison, we can find that so we verify the conservation of complex number, that is the conservation of the active power and the conservation of the reactive power. Well, that's the end of introduction to the power under SSS.